Okay, this is part 2 on 6B coordinate geometry. So on this section, we're talking about triangles and quadrilaterals. Classifying triangles, they gave you the distance formula again that we see right here. There are things you need to remember. This is from geometry days. Let me go ahead and flip this to get that, and let's see if I can make that a little bit there. If you remember if you look on the green box there, when C is less than A squared plus B squared, they said it's an acute triangle. So what does that look like? Basically something like this. So that would be an acute angle. So acute triangle, I apologize there. What happens when C squared is equal to A squared plus B squared? We get a perfect right triangle. What happens when C squared is greater than A squared plus B squared? Then the triangle kind of looks like this. That being C. That's C. Like that. C. So, as you can see, here at the bottom example here, that would be obtuse. Over here would be right triangle. So, okay, let's move it on. Let me go ahead and put it back to, let's see, whoops. What did I just do? Go back to lesson. So let me go back to lesson and go back to the integrated camera here. All right, so let's look at our examples. The vertices of a triangle are listed below. So here we go. -2, 3, 2, -1, and -2 and -5. So you're just basically doing the distance formula again. So as I did for AB, they go ahead and get the x coordinates, which is 2, x2 is 2, x1 is -2, so it'd be 2 minus -2 squared. They do grab the y coordinates, which are -1 and 3, so we plug them in down here, -1 minus 3, and then square it. So this becomes 16 right here. This becomes 16 right there. So together, it is the square root of 32, which is 4 square root of 2. Length side. All right. BC, you're going to do the same thing with the numbers they give you for x1 and x2 and y1 and y2. You get the value, you crank it out, same thing, same number, and the length squared is 32. For the third length, CA, that would be this point and that point. So that would be -2 minus -2. And if you look down here, that's how they have it set up. That becomes 2 plus 2, that's 0. So that's 0 for that part. And then 3 plus 5 is 8. 8 squared is 64. Here it is, square root of 64 equals 8. So there is your length. 4 square root of 2, 4 square root of 2, and 8. That looks like a right isosceles triangle, you guys. So go ahead and notate that. Let's see. Oh, here we go. The x2 and y2 and x1 and y1, those are points that we also use for the slope. As you look at the slope formula down here below, for classifying quadrilaterals, use the slope formula to find the slopes of the sides of a quadrilateral. The slopes of the sides can determine if the quadrilateral is a parallelogram. The slopes can be determined if the sides are perpendicular. So if you remember how you can tell if two sides are perpendicular, the slope of one has to be the negative reciprocal of the other slope. That's how you know it's perpendicular. So there goes my email. Okay, so let's use the distance formula, which to determine if adjacent sides of the quadrilateral are the same length. So, all right, so here's our example number 2. They throw us 4 points. As you see, they use the slope formula for each one. QR, they grab the slope for QR, they grab the slope from RS, they grab the slope from ST, and then from TQ, which is last point to the first point. They do the calculations for you, and they show you how it gets done. And for this one, the QR, the slope is -1. For RS, the slope is +1. The slope of ST is -1, and the slope of TQ, the line, is 1. So if you look at the slopes, they're all negative reciprocals of each other. So that should tell you that is definitely a rectangle or square. Now let's try to find the distances. If we look, we're going to use the same values, the x1 and y1 and x2, y2. So for QR, we're going to use these numbers. 6 minus 0 is the y down here, and then -4 minus 2, square that. That becomes 6 minus 0 is 6, so that becomes 36. -4 and -2, that becomes -6. When you square that, that becomes 36. So you get the square root of 72, and then when you put that in a calculator, your length comes out to be 8.49. You do the same thing for the other length of the quadrilateral, which is RS, and you will get a length of 4.24. So you know right off the bat, since you got the length of one side, which is 8.49, and then the length of another side, which is 4.24, is it a quadrilateral? Absolutely. And is it a square? No, because the lengths are not identical. So this quadrilateral is a rectangle. So, and that is it for part 2 of 3. Let me go ahead and stop recording.